Hi everybody, this is a video to show you how to use your TI-84 to assist you in your Bungee Barbie lab. So if you didn't get a TI-84 out yet, excuse me, got a scratchy voice tonight, go ahead and get your TI-84 and then you can pause the video and resume once you have it. But the first thing we want to do is turn your calculator on, and the way we do that is just the bottom left button here. You're going to turn it on. Sometimes when you turn on the calculator, you'll be pulled up like to a screen that looks like maybe something like this, or maybe you're in a different menu and you can't figure out how to get out of it. So the first thing I'm going to show you is how to access these keys that are in blue. Anything that's in blue on your calculator, we're going to hit the second key before we can use those features. So I want to quit out of anything that's open on my screen. So I do that by pushing the second key, and then this word quit will be activated since I pushed the second key first. And now you should have a clear screen similar to what I have here. So now that we all have a clear screen, we want to also clear out any work that other students have done. It'll just make the setup a lot easier so we're all on the same page. So the feature we're going to use is the memory feature. It's in blue. So we're going to go up here to the second key, and then we're going to push the memory button. And we are going to clear, we're basically going to actually reset the entire device. And so you can either hit the down arrows to scroll down, or you can just look at what number you want to select, which is 7. And you can just push the 7 button, and it will go into that menu. We're going to clear the entire RAM, so I'm just going to press enter. It will ask if I really want to do that, so I'm going to select option 2 and say yes, I want to reset my TI-84. Okay, now we all have the same settings. Everything is back to the default way that it came when we purchased this, which makes it a lot easier for us to work with it. So I would always suggest doing that before you start any work. And it just seems to kind of make the process a lot easier with whatever we're working on. So we're basically going to do 2 things. I'm going to show you how to, well, 3. I'm going to show you how to put your data in. I'm going to show you how to create a scatter plot of those points. And then I'm going to show you how to create a linear equation and see if it really describes the line of best fit that is supposed to mimic your data, or explain your data, I should say. All right, so in your lab, I'm just going to pull up my sample document here. You should have collected data. Now, I didn't fill the whole thing out since this is a sample, but you should have 3 trial distances for each rubber band that you added. And if you don't have that, you may need to go back through and collect all 3 distances. And then this last column here is just a mean of the 3 collections with 1 rubber band. And so I averaged those out, and I got 9.33. Okay. So what we want to do is enter this first column as our independent variable, in other words, the x's. And we're going to enter this last column as our dependent variable, which would be our y's. All right, so we're just going to go into the TI. The feature that we're looking to use is called, it's under the stat menu. So go to stat, and we'll choose edit, which is option 1, and this is going to allow us to edit our data. This first column will be the independent variable. Second column is the dependent. You can always switch those around, but the defaults, the calculator will always make this first column the x's and the second column the y's. And so you're best not to go up here and rename anything. It's just easier if you keep it at L1, L2, etc. So I'm going to enter our x values, or our independent values, which was the number of rubber bands. And we're going to put that in the first column. I had 7 data entries, so I'm going to include all 7 values. And if I hit the arrow to the right, it will allow me to enter the dependent values. And so I'm going to see if I can try to squeeze these both on the screen at the same time. Let's see if I can get those typed in. Now, at this point, you can look at your lab and type your numbers in. I'm just going to use these sample ones for mine though. So 9.33. All right. So go ahead and do the same numbers from your lab, and you can pause the video if I get ahead of you, and we'll resume here in just a minute. Okay, so at this point you should have your data entered in the independent variables column, which is the first one, as well as the dependent values in the second column. And what we're going to do now is go to your Y equals menu, which is the top left button, and we are going to create a scatter plot. All right, so the way we do that is we arrow up and we just press enter over plot 1, and if you arrow back down, you can see that that's black now. That just means when we graph it, it will actually plot the points for us. Okay, so let's graph it and see what happens. The graph button is your top right key, and we only see one data point. Well, the reason that's happening is because they are standard setup of this calculator will always set the window settings to go from -10 to +10, and then on the same thing on the y-axis, it will be -10 up to +10, and you're scaled by 1 unit. What we want to do is look at our data set, which was right here, and realize that I always like to make sure I can see the x and y axis, so I usually start at 0 or a negative number, just a little bit smaller than that, and make sure we get all the way up to our highest value. So the way we can change the window size is to hit the window button, and that's in red here that I just clicked on. All right, now the x, we're looking at the horizontal axis. I don't need to go all the way back to -10 because my independent variable started at 1. So I'm just going to start that at -1, and I'm going to let it go all the way up to 10. So that's my x max, and then this third one is the scale. I'm just going to scale it at 1. All right. The y's, if you remember, those went all the way up to like 40 something. So I'm just going to start those at, say, -5, just so that way I can see my y-axis on the screen. And I'm going to make the maximum 50. And I'm going to scale this by, let's go by 5s. So every tick mark will represent 5 units. You don't have to mess with the resolution or the delta x down here, where that has nothing to do with what we're working on right now. So now if we hit graph, now we should be able to see all of our data points. And to me, yeah, this definitely looks like we have, at least my data here, it looks pretty linear. All right, so my next step then is to actually create the line of best fit. So instead of just guessing, the calculator has a linear regression model, and we can use that to determine the line of best fit. So what you will do is you'll go into the stat menu, and instead of editing your data, we're going to arrow to the right and choose calculate or calc, and we are going to do a linear regression, which is, linear regression is a fancy name for line of best fit. Okay, it's option 4, so I'm just going to select the 4. And it pulls up a menu that asks me which lists I want to use. Notice the X, or our independent, is selected for list 1. That's what we want. And then this, again, these are the defaults. And then the Y list is L2, so I'm going to leave that alone. If you don't reset your laptop, that can get kind of messy. And we're not going to mess with that in this class. So just reset it before you begin each unit. I'm going to arrow down to calculate. And basically what this does is it actually does your slope calculation right here. And it does your y-intercept here. All right. And if you notice your model, y is our dependent variable. Equals a here would be our multiplier. So that's our slope. I don't know why they don't do m in this graphing calculator, but that's the way they do it. M is our multiplier, or a in this case is our slope, and then b is our y-intercept. So we can use that now to write our model. Okay, so I'm going to just try to pull up again both screens so you can see this. Let me see if I can pull that up. There we go. Okay, so our format was y equals ax plus b. And y is our output. So our output was distance equals our slope, or in this case, our rate of change, which was our a value. And you can see that down here. I'm going to round that to 6.54. The units were either like inches per band or centimeters per band. I'm just going to say inches per band. And then we're going to multiply that by our independent variable, which was inches. Or I'm sorry, not inches. It was number of bands. And then we're going to add in our y-intercept, which is 3.33 bands. Okay, so that would be our math model. Again, this would be our slope. This would be our y-intercept. Okay, so to clean that up so it's kind of written in y equals mx plus b form, I'm just going to say y equals 6.54. Number of bands was on the x-axis. That's my x plus 3.33. Okay, and the reason I'm rewriting it is because the TIs don't allow you to enter units in your equations. And so this is what we're going to type in so we can actually see if this line kind of fits the data set that we were working with. All right. At this point, you might want to pause the video if you have any questions and address those with me or a teacher before you move on. Otherwise, our next step is to now graph it. So if we're doing a y equals equation and we want to graph it, you just go up here to the top left and you go to y equals. How convenient, right? All right, and we're going to enter the right side of our equation. And you can do a lot of different equations. We're only going to do one of them right now. So I need 6.54x plus 3.3. So that's the one we just recorded. Plus 3. Okay, come on. There we go. 3.33. And if I want to graph it now, I just hit the graph button. And now look at that. There's our line of best fit. And the calculator did all the work for us. So that's pretty sweet. Our y-intercept, remember we scaled by 5. So yeah, what was our y-intercept? 3 point something. 3.33. Well, that seems reasonable. Here's 5. So there's 3.33. Our slope was positive, so we're increasing as we move to the right. Gosh, I wish TI would set this up so you could actually see the scale. That's a little bit annoying, but you can always go back into that window and go, oh yeah, I scaled by 1s on the X and I scaled by 5s on the Y. So we know this is 5, 10, 15, 20, 25, etc. And at this point, what you're going to want to do is make sure you've recorded your model. In this format, distance equals slope, includes units, times the number of bands, plus y-intercept. And then we're going to use that to make some predictions. Thanks for watching.